Welcome to the deep dive. Picture this. It's 2025, your software shop is buzzing, pull requests are flying, CI/CD pipelines are humming, and you've got these AI co-pilots just dropping suggestions everywhere faster than you can even keep up sometimes.
Right, it's becoming the norm.
Exactly. And two names keep popping up again and again, Claude Opus 4.1 and Gemini 2.5 DeepThink.
The heavy hitters.
For sure. Both claiming, unmatched intelligence. They've got these amazing benchmark charts.
Yeah, the charts are always impressive.
And they're both vying to write your next commit, basically.
It's a real race.
Now, cutting through all that marketing fog, it's not just about being curious, is it? It's actually pretty crucial.
It absolutely is. Your team speed, getting features out the door.
Your velocity?
Yeah, your velocity. It lives or dies on having tools you can actually rely on.
Totally. So our mission today for this deep dive is pretty straightforward. We want to help you figure out which of these powerhouses really belongs in your tech stack. Give you enough context maybe for those leadership slides, but also, and maybe more importantly, practical takeaways for you, the developer, the person who needs the right tool, like now.
Right. What works by the end of the sprint.
Exactly.
And maybe a good way to frame this whole thing, this competition, is to think about it as, well, specialist versus generalist.
Specialist versus generalist. Okay.
Yeah. Claude Opus 4.1, as we'll kind of unpack, it really nails the messy, hands-on engineering work, where code meets the actual business logic, the cache.
Okay.
Gemini 2.5 DeepThink, though, that's more about raw abstraction, just sheer brain power.
Ah, interesting.
And understanding that split, that fundamental difference, I think that's going to guide pretty much every decision, from sprint planning right up to, talking to the CFO about token budgets.
Okay, let's dig into that then, this core idea. Specialist versus generalist. You said Claude Opus is the specialist. What does that actually mean when I'm, say, trying to ship a feature?
It means it's built for precision, right where it matters most, where the code you write actually impacts the bottom line, impacts revenue. Think of it like maybe a really skilled surgeon, focused, practical, dealing with the real world.
I like that analogy.
Whereas Gemini 2.5 DeepThink, the generalist, that's more like your brilliant theoretical physicist. Pure brain power, amazing at handling really complex, raw abstraction.
Right.
And look, this isn't just some marketing stint. It's baked into how they operate, how they're designed, and crucially, where they actually deliver the most value.
That surgical precision, that sounds incredibly valuable for engineering teams. Let's go deeper on Claude Opus 4.1 then. What specifically makes it the go-to for, serious coding?
Well, Anthropic calls it a hybrid reasoning model. But what that really means for a developer is it can handle serious complexity.
Like what?
Like reading diffs that are thousands of lines long, spotting those really annoying off-by-one errors that can ruin your weekend.
Oh, yeah, been there.
We all have. And it holds context really well across a huge window, 200,000 tokens. That's substantial.
Wow.
But maybe the most impressive thing, it scored 74.5% on SWE-bench. That's the software engineering benchmark.
SWE-bench, right. And that's not just synthetic tests.
No, exactly. That's the key. It's a real-world test, GitHub grade, using actual bugs from open source projects.
Oh.
So that 74.5%, that really says something about its practical coding skills.
Okay, that 74.5% on real bugs, that definitely catches the eye. You also mentioned it builds Agentic AI Workflows. What does that look like day-to-day for a developer? How does that boost productivity?
Yeah, it's pretty cool, actually. It's not just giving you suggestions, right? It actually plans out the tasks.
It plans?
Yeah, it figures out the steps. It calls external tools when needed, like linters or build tools. It looks at its own output, reevaluates, and then it loops. It keeps going until the test actually passed.
It keeps going until tests pass. That's pretty autonomous.
It is. And we're seeing companies like Cursor, GitHub, Rakuten, they're reporting big productivity jumps.
Yeah.
Especially on those nasty multi-file refactors.
I can imagine. Less tedious work.
Exactly. Fewer weird import errors, fewer unexpected side effects, breaking things elsewhere. And, when the finance folks look at it, they see faster cycle times. Plus, frankly, happier developers. The AI feels more like a collaborator.
That sounds almost, magical. But you mentioned something called extended thinking mode. Sounds powerful, but maybe slower. Tell me about that.
It is powerful, definitely.
Yeah.
And yes, there's a trade-off. When you flip that flag and you give it a bigger context window, maybe up to 64,000 tokens, it deliberately slows down.
Okay. Why?
Because instead of just spitting out the answer, it actually narrates its thinking process in plain English.
Like showing its work.
Exactly, like peeking into its internal monologue.
Yeah.
And that transparency, it's huge.
How so?
Well, think about auditors. They can trace the logic. Engineers can spot iffy assumptions before bad code gets merged. If you're in a regulated industry, compliance heavy. That kind of auditable trail builds enormous trust.
Okay, give me an example. Where does extended thinking really make a difference? What's the real trade-off in time versus insight?
Right, it is a trade-off,
Hmm.
but often worth it. So there was this lab, right? They gave Opus 4.1, this horrible legacy service, 60 files, broken tests, 0 docs, the usual nightmare,
Sounds familiar.
doesn't it? In standard mode, it fixed 4 issues. Took about 12 minutes, not bad.
Okay.
But then they ran it in extended thinking mode. It took about double the time, yes. But it fixed 9 issues, 9. And it commented the data flow, and it suggested adding a caching layer for optimization.
Whoa.
Yeah. So time cost doubled, but the bug count dropped by 2/3. You weigh that against the human hours to do the same.
Yeah.
That extra AI time looks incredibly cheap all of a sudden.
Okay, fair point. So if Claude Opus is the coding specialist, the surgeon, where does Gemini 2.5 DeepThink come in? The generalist, you called it. Where does it dominate?
Gemini 2.5 DeepThink is playing a totally different game. Its sweet spot is open-ended reasoning tasks.
Open-ended reasoning.
Yeah, think big abstract challenges. And its academic benchmarks, they're frankly mind-blowing.
Like what?
It scored 34.8% on humanity's last exam. That's a test designed to push AI to its absolute limits on general intelligence.
Okay.
And get this, 60.7% on the International Math Olympiad 2025 problems. That's incredibly hard math.
Seriously, IMO level.
Seriously.
Yeah.
It even gets like 99.2% on high school competition math, the AA 2025. So researchers, academics,
Yeah.
anyone looking for pure symbolic horsepower, a really high ceiling for abstract thinking, they lean towards Gemini.
That is some serious intellectual firepower, no question. But back to the trenches. For the folks listening who are building products, writing application code, how does that academic brilliance translate? What are the real-world uses outside of, math proofs?
That's a great question. Think about tasks that need deep abstract reasoning, more than just knowing specific code syntax.
Like
AI agents planning entirely new drug molecules, or proving formal properties of complex software systems, like ensuring safety protocols mathematically, or even exploring new strategies in complex games.
Ah, okay. So things that require understanding cause, effect, long-term planning.
Exactly. Gemini 2.5 DeepThink provides that incredibly high ceiling for reasoning. It uses something called world model priors. Basically, it builds an internal understanding of how things work, cause and effect, time.
A model of the world.
Kinda, yeah. And that lets it reason more effectively, juggle complex ideas, often using fewer tokens than you might expect. It's very efficient for that kind of abstract problem solving.
Sounds amazing for those specialized areas. But you hinted earlier it can struggle with practical code sometimes. Where does Gemini stumble in day-to-day development?
Yeah, that's the flip side. That's the core contrast, really. Its abstract power is immense, but drop it into a typical messy code repo.
Uh-oh.
And it can sometimes get tripped up by the mundane stuff. A missing environment variable, a flaky build script, those weird tool chain quirks every project seems to have.
The stuff that drives developers crazy.
Exactly. That gap in, let's call it practical resilience. That's why a lot of the popular dev tools, the coding assistants, they still tend to rely on Claude Opus 4.1 for the actual hands-on coding and refactoring.
Makes sense.
Meanwhile, the research labs, they're all over Gemini 2.5, DeepThink for the proofs, the theoretical breakthroughs, exploring brand new problem spaces, different tools for different jobs.
Okay, let's talk benchmarks again. Because they aren't just bragging rights, right? They drive decisions, they drive budgets. What do the numbers really tell us? Where does each model truly lead?
Yeah, the numbers paint a pretty clear picture, aligning with that specialist generalist idea. Gemini 2.5 DeepThink basically runs the table on the abstract stuff.
Runs the table. How so?
It leads big time in code generation, 87.6%. Now that means generating syntactically correct code, maybe not always perfectly integrated code, but still.
Impressive generation capability.
Right. And it dominates reasoning and knowledge at 34.8%. Advanced math, as we said, 60.7%. And high school math at 99.2%. It's the abstract reasoning king.
Okay, and Claude?
Claude Opus 4.1 owns the practical coding and tool-driven workflows. It leads in agentic coding, that's the 74.5% on SWE-bench, fixing real bugs, and agentic tool use at 82.4%, using tools effectively.
Got it. And OpenAI's model, O3.
Yeah, OpenAI O3 is still a really solid performer, kind of a strong middle ground, but it definitely trails these two leaders in their respective specialist lanes. It doesn't quite hit the peaks of either Opus for coding or Gemini for reasoning.
Okay, this brings us right to the crucial point then, the potentially million-dollar question for some teams. Based on these numbers, this discussion, which model should you, the listener, actually pick for your backlog? Where should the money go?
Right. Let's try a quick guide. If you're a developer, a startup, an enterprise team, and your main goal is feature velocity, getting solid deployable code merged,
Shipping fast.
shipping fast and reliably, then Claude Opus 4.1, our specialist supercar, is probably your best bet. It excels at mission-critical coding, those agentic workflows we talked about, complex automation. Its strength is pragmatic results, code that works.
Makes sense. The supercar for the coding track.
Exactly. Now, if you're in a research lab working on academic projects, maybe trying to solve fundamental scientific problems, modeling complexity, pushing AI boundaries.
The theoretical physicists.
Right. Then Gemini 2.5, deep think the F1 engineering marvel, that's likely your tool. Deep scientific reasoning, advanced math, raw abstract problem solving. Its strength is peak intelligence, peak reasoning power.
Okay. And what about teams kind of in the middle?
Good question. For more balanced IT shops, maybe doing a mix of standard enterprise dev and some exploratory work. Claude Sonnet 4, think of it as the workhorse sedan, offers really high performance but at a much better value. Great for balanced workloads, daily coding tasks. It's a very strong contender if Opus feels like overkill or too pricey.
Let's talk price then. Because, yeah, Opus 4.1 isn't cheap. $15 per megatoken input, $75 output. That's significant. That's going to cause some sticker shock for sure.
It absolutely can, no denying that. But I think it's really important to frame it not just as a cost, but as an investment in your engineering velocity.
How do you mean?
Well, think about it this way. A week's worth of token spend on Opus 4.1. That might only equal 1 day of a senior developer's time.
Ah, okay. Put it in perspective.
Exactly. I mean, I remember this one bug. It took 3 of us nearly a day to track down manually. If we'd had Opus back then, especially with extended thinking. So for many teams, that premium price, it can easily pay for itself if it helps you avoid just one serious production incident.
Right.
Or ship a major feature just 1 week sooner. Looked at that way, the ROI can be pretty compelling. It becomes a pragmatic decision.
And you mentioned the other Claude models for comparison.
Right, yeah. Claude Haiku 3.5 is way down. It's already 80 cents input, $4 output per megatoken. Much cheaper.
Yeah.
And Claude Sonnet 4 is in the middle, $3 input, $15 output. So there are definitely options depending on budget and need.
Okay, so let's say a team is convinced they're ready to implement one of these. What's the blueprint? How do you actually get started integrating them smoothly?
Okay, for Claude Opus 4.1 specifically, there's a sort of migration cheat sheet. Pretty practical stuff.
Lay it on us.
First, obviously, change the model name in your API calls. Claude Opus 4.1 2250.8 Easy enough.
Okay.
You might find you can lower parameters like temperature or top overlap compared to older models, which can speed things up. Old prompts might even run better.
Good tip.
If budget is tight, try to keep your context under 32,000 tokens. Cache prompts aggressively. Maybe flush long conversation logs after each task cycle to keep costs down.
Smart.
And really important for safety and trust. Enable that reasoning choice feature. Review the AI steps, and if you're dealing with sensitive data, constrain any external API calls it might make using strict sandbox policies.
That makes a lot of sense. What about a more general implementation blueprint for any team wanting to integrate either model effectively, say, into CI/CD?
Yeah, definitely pilot both. Don't just pick based on benchmarks. Create a feature branch, grab a real ticket from your backlog,
A real task.
a real task, feed it to Opus 4.1, then maybe take a different kind of task, feed it to Gemini 2.5 Deep Think, and compare.
Compare what specifically?
Compare the actual pull requests they generate.
Yeah.
Compare the latency, how fast you get results. Compare the quality of the code, the review comments needed. Pick some key metrics you care about, like defect closure rate. Maybe even tie team bonuses to improvements.
Interesting.
Start with smaller token windows, like 32K. Only expand if the task complexity or maybe the tracebacks truly demanded. Log every prompt, every response. And definitely put safety hooks in place. Pass AI outputs through regex guards or other validation steps before they go live.
Okay.
Then iterate. Promote the model that wins for your main CI jobs. But keep the runner-up handy. It might still be better for certain niche tasks.
That sounds like a solid, pragmatic approach. Now, looking ahead, there are always rumors, right? GPT-5 is inevitably out there somewhere. Should teams pause, hesitate on adopting Opus or Gemini now because something new might be coming?
Honestly, my strong advice is don't stall. Don't wait.
Really? Why not?
Because you future-proof your systems through good design, through clean abstraction, not by waiting for the next shiny object.
How does that work in practice?
Wrap your calls to the LLM, whatever it is, in a thin client layer. Make it easy to swap out the back end. Log your prompts meticulously. Version your tests that use the AI.
Ah, so you can switch engines easily.
Exactly. If you do that, when GPT-5 or whatever else arrives, you can swap the engine out in hours, maybe a day, not weeks of refactoring.
Yeah.
Until then, Claude Opus 4.1 and Gemini 2.5 DeepThink. They form a really reliable, powerful two-horse ecosystem you can build on today.
Okay, don't wait. Build adaptable systems. Got it.
And looking further out, say late 2025, the race will continue, for sure. The focus will likely be on maybe 3 key things: even bigger context windows, better retrieval precision, finding the right info in that context, and always cost per token.
The eternal balancing act.
It is. Anthropic's hinting at more leaps. Google's investing heavily in those world models to make agents smarter. OpenAI, well, GPT-5 is waiting in the wings, no doubt. A year from now, yeah, maybe this conversation sounds a bit quaint.
Maybe.
But the core principles, they'll hold firm. Measure real task performance, not just hype. Pay for the output you actually need, not just bragging rights about parameter counts.
Yeah.
And just keep experimenting. Always be testing.
Okay, so let's try and summarize the main takeaway from this deep dive then, if we boil it down.
Go for it.
Claude Opus 4.1 seems to be the clear winner for the day-to-day coding grind, right? It drives those secure agentic AI workflows, and it genuinely seems to pay for itself by getting code merged faster, reducing those cycle times.
Yep, that's a fair summary for the practical coding side.
Whereas Gemini 2.5 DeepThink, it takes the crown for abstract reasoning, pushing the boundaries of theory, acing those incredibly tough exams like humanity's last exam, the big brain stuff.
That captures its strength perfectly. Peak reasoning power.
So the challenge for you, the listener, is to figure out which crown matters more for your specific needs right now.
Exactly. Use the insights we've talked about. Run those pilots we suggested.
Right.
Test them on your actual work. Keep a close eye on your token spend, and just stay nimble. This field moves incredibly fast.
It really does. You know, nothing about software in 2025 feels slow. But the really thoughtful teams, they still manage to ship the right things at the right pace.
That's the key. Not just fast, but effective.
And it sounds like with the right model, which for many might often be Claude Opus 4.1, but sometimes for specific challenges, Gemini 2.5 Dupe, think you can keep that crucial advantage while this AI race just keeps storming ahead.
Well said.
So maybe the final thought for everyone listening is, how can you apply these distinctions? How can you use the specialist versus generalist idea to pull ahead in your own work, your own explorations?